Hey guys, welcome back. So in this video we will learn about multi-index and tables structure of EOS iOS smart contracts. So what is multi-index? Multi-index is a way of providing a C++ interface to the EOS iOS database. It is a way that the data is stored in database or tables in the EOS IO. So let's take a look at it. I have made a basic structure of the smart contract. Here we have insert, get, update, delete all. So we will perform basic operations or CRUD for the tables and implementations. So our project is project 6. Firstly, we will declare in the private section we will create our table. So the table is created using the struct and EOSIO table attribute. Struct and EOSIO table, and we will after that we will give our name, the table or struct name, transfer, and here we will define the attributes of our table. So let's first mention a primary key uint 64_t and name it as id. Then we can name it as sender, receiver, and an asset type, tokens, fees for the double, and one more for a bool variable for testing. Is the transaction completed or not? It's just for the testing. So this is how the structure of the table is defined using the struct and EOSIO table, the name and the attributes of type that we want in the table. So after that the table requires a primary key that is necessary, and for that we will describe the function that for the primary key, and yes, the primary key is of uint64 type and is a unique one, so it will not be duplicated in the table. So let's define a function for the primary key uint64t, and this is the function that is defined, primary key, and then we will use constant, and this will return our primary key attribute, that is the id. The id is the primary key attribute, and this function is used to get the primary key for the table, and it is necessary, so we will return the id column in the primary key function. So this is the basic structure for the table with a single index primary key, but EOS allows secondary indexes as well. So when the primary key is unique, the secondary index could be repeated, and up to 16 secondary indexes are available in the EOS structure. So let's define a secondary index here. The secondary index could be of type uint64, 128, double, long double, or name, etc. So we will define a name secondary index. Let's name it second index. Okay, this is our second index, and for the second index as well we have to define the function similar to this. So let's define it and name it secondary key. And because our the secondary index value is of type name, so we cannot return it here just like this, because we will need the integer value. So we will define it like this. We will return the value of the secondary index. So here is the complete structure of our table with one primary and one secondary index. So one more thing is needed to define the multi-index and to define it this struct as a table. So we will use type definition and EOSIO multi-index here. So what is this? The type definition. The type definition is a way to alias types. Here we are aliasing multi-index type that we will see here. So the EOSIO multi-index is taking three variables or three parameters here. The first one is the table name, then the type of the data stored inside the table, and then the indices, an index that are the secondary indexes as well. So the first parameter, as we talked, is the name. So we will give the name transfers, and after that name transfers, and after that the type of the data. So the type of the data will be this struct transfer. Okay, so we will give the struct name here as the type, and any secondary indices. So we have one secondary index, so we will define it here like EOSIO index by, and here again we will give the name of the index secondary index and of type name. Then we will mention here EOSIO constant one. Don't get worried about the syntax. It is just a way of defining table structures and definitions, and the multi indices in them. So in this we will define the struct name and of type our keys type, that is of UN64, and the pointer for our transfer secondary index function. So here we go. The type definition is multi-index transfers, and then the type of our struct EOSI, then index EOSI index secondary index, and the definition of our index type UN64, and the function towards returning the secondary index value. And in the last we will define transfers name. So this is it. And if we have for For now we have a one secondary index. If we have multiple secondary index, we could define it like this, and changing the names and the functions by providing this. So this is our tables definition. Now we will move towards the insert function here. So in the insert function, we will use we will input some parameters that will be required for inserting in the table. So first of all, let's take the second index, the same for receiver, sender, then is our asset of type of tokens. Sorry, the asset is the type, and the name is our tokens, and our double fees. So these are the parameters that we will take, and we can take the sorting just like it is here. So there are two parameters missing, the ID and the completed. We will define them in the table directly. So for accessing the table, we will mention transfers, our table name, and then we will give alias for this, or we could use transfer, and we will use then get underscore self. The get self function is used to get the name of the caller or the contract, and get first receiver. These are the get first receiver. These are the basic values that are passed in the instantiating the tables object. So we will pass get first values transfer here, or value. So here is the object of our table ready to be inserted or updated. So for insertion, we will use the same method we have used for the vectors, that is in place. So by calling the table transfer object dot in place, and then we will give the same get self, and these are some syntaxes for tables. These are basically the templates. Just take the syntax and don't go in the details for now. So this is the syntax, and here will go the body for the insertion of our tables object. So first of all, we will insert the raw, and the raw ID will be auto generated because it is the primary key. So we will get the available primary key to be inserted here. For this we will do table transfer dot available primary key. So this will return the most recent available primary key, and that will be inserted in the ID column. And same will be we will do for the secondary index, but the secondary index will pass from the parameter, so it will be like this. And we will copy this, and the sender value that will come from the parameter the receiver value, again from parameter the tokens, and the fees value, and the one value that we have given here we will give it here by default true. So that is the insert function here that will be used to insert in the table transfers, and it will retrieve the available ID and pass the passed parameters will be inserted in the table. So this is our insert function. Let's go towards get function. The same will be instantiated here. You can also instantiate it on the global level, so it does not require again and again instantiate it, but for now we will instantiate it here. So for getting the records we will use auto. We will use the iterator here, and use the object name dot find. But remember this default find method on the table will find the value on primary key index, not the secondary key index. So if we give any value here, let's say 1, it will find in the primary key object, that is the ID, and return the iterator of that index here. So we will use the iterator here to return iterator to get the values that are found on that index. So let's print some values that are found here. So iterator, it is for accessing the values in the iterators, or we could also use the pointer that we have previously used. Let's give it a space for the separator and print the values here. Okay, good for now. So this is the method to get the values from the table by providing any input here. We could also use a parameter here like this to get the ID as a parameter. So it will be dynamic. It will return the data from with respect to the IDs. So we have covered insert and get. Now let's move towards the update function. Let's take this here, and for updating we will use the combination of both functions, sort of. We will first instantiate the table, then we will find the provided ID for update. The ID will be provided so that we will search it in the table and update the records of that ID. So once the ID is found and the iterator is returned, we will use the modify function on the tables instance to modify the records, and it is the same as in place function, just like it will take the one more input, the iterator here, before the get self. The iterator is the index that is returned from the table's ID position that we have searched. Okay, so once the iterator is returned, we will pass the iterator in the modify function and we will mention the values here that we want to change. So let's say we want to change these values. So we can give it here. So these values will be modified once the item is matched. So here is our update function. So this was the update function. Now we will get to the delete function. Sorry. So for deleting, we will require the same. The ID parameter will be input through the parameter. Oh, we have missed that. Same will go here. So the ID parameter will go here, and we will search the ID, and that will return the iterator to us that is found. So we will simply pass the iterator to the function table transfers erase function, and pass the iterator to erase. That's it. So this will remove the record that is returned in the iterator found from the ID. So let's move towards the delete all function. What will the delete all function do? The delete all function is similar to the delete function, except the delete function is only deleting the single record. The delete all function will erase the table completely. So of course, one more thing we can use here is the authority function, the require auth function. The require auth function is used to confirm the authority of the user, that the user is valid or not. So we can require authority of our user Bob that we have deployed the contract on, that if the creator is calling the delete function or not. It's like that the only creator of the contract will be able to call this function or to delete the records in the table. Let's put same on delete all function as well. So in the delete all function, we will use the iterator function begin, and no ID parameter will be passed because we will iterate over the table. So let's use a while loop here till the iterator is not equal to dot end, that we have used in the vectors example. It is similar to the vector. So and inside it we will call the erase function, and in the erase function we will use iterator erase and pass the iterator that is obtained in the while. So what this while will do, this will initiate the table's begin index in the iterator and will move towards the iterator and remove all the values from it. So this is the delete all function. One more function we could use is by getting the results or record through the secondary index. We have used the get function to get the result on behalf of the primary key, that is our main index. We could also use the get second function to get the values on the secondary index, or by passing the value of secondary index. So we could name it by index 2, get by index 2, and the index 2 is of type name. We could second index. So there is a little change in getting the records from the second index. By default, as we have discussed, the find method returns the record from the primary key. So we have to change something. We have to change the index. For that, we will do auto second index, and then we will use table transfer get index. The get index function is used to get the index value of our index, and here we will define what index we are searching for, and we are searching for our secondary index, that is here the secondary index. So where it has gone, so it will look something like this: the table transfer get index and the name of our index, and after that we will mention the round brackets. So after that the iterator will not be directly from table transfer, it will be found from secondary index, and the value of the passed parameter. So in this case we will get the value through our secondary index. So this is our smart contract for the tables. Let's deploy it and test it if it's all good. First we have to build it. Oh, there are so much errors. Let's remove them one by one. Okay, so we are having these troubles here of brackets and terminators. Okay, so our contract is compiled. Let's deploy it. Wallet, EOS wallet. Your wallet will be automatically locked if it is idle for 15 minutes by default. You can change the time in the config of wallet. So here is our contract is deployed. Great. Okay, so now we will go through these functions one by one. Our insert function. The insert function will contain the parameters that are, the first parameter will be the secondary index. That will be we give any value index val 1. So these are our parameters that I have entered. and we are calling the insert function. So let's insert it. Great, the function is called and the values will be inserted here. So if the values are inserted, how do we check the table? So here is the command EOS get table and our contract name and user and our table name first. So wait, oh, it contains the values previously that I've entered. Okay, so these are the rows that are entered in the table before, or anyways, there are 4 rows and they are entered in the JSON format, and our keys are there. The ID, the secondary index, the sender, receiver, tokens, fees, and completed. So okay, let's check the delete all method first. Bob, delete all. So great, our delete all function works perfect, and all the rows of the table are deleted. So now let's insert fresh row again, and one more row with 250 tokens and Alice to James, and with index value of 2. So there will be 2 records now in the table. Great, with 0 and 1. You can check it. It is assigning the IDs in the sequence order and automatically, and the index, secondary index, is given by us. So these are the values that are inserted. So similarly, we can call the update and delete functions so similarly we can call the delete and update functions to modify and delete a single record in our table. And okay, let's call one time the get function. By passing the ID. The ID is passed 1, so this record should be printed here. Okay, great. The ID 1, index value 2, Bob James, 250 tokens is printed. So this is the get, and same will go for the secondary index. So this is how our CRUD works. So we can also get the table rows with some index values, or like a query language by defining upper and lower indexes from the cleos command in the get table function. So here is the cleos get table. So let's clear it first. Here is the get table function. So we could use upper, and by defining our upper value for if we want to get upper value 1, that is for the Bob and James transfer, upper value 1, and key type, that is the key type that we have to mention. The key type is of integer. So, and of course we have to mention the index number 1. Okay, so no, it does not work like that. We have to give it like on the secondary index of name and the index type 2, and the value of our secondary index, that is index value 2, index val 2. Okay, so it does not work like that, it matches like that. We have to mention the lower part as well if you want to get the record of a specific value. So for the upper bound and the lower bound will be the index 2, and key type name and index is 2. Index 2 means the secondary index or the second index. The key type means the name that our index is of. The secondary index is of type name. So here we go. The secondary index of value 2 is here, and similar we can do it for the key type integer of our primary index by mentioning lower bound of 1, right? So it matches the 1 index, the upper and lower bounds, and it is returning only 1 rows instead of 2. So this is good for now, tables, and great. Thanks for watching. Have a nice day.